Alright, if I remember right, we left off right here with the choosing the best method to solve.
Yes.
And that's what I want you guys to be able to look at and determine and decide what is my best method. So we're going to go through and look at what is the benefit of each of them. So graphing. Can you use it all the time? Sometimes. Sometimes. When could you not use it?
When it doesn't have the right like numbers.
True. When does it not work?
We have no.
What did you say? No. When would it not cross the x-axis?
When there's no solutions.
Why would there be no solutions? What do we call that? No, it's Monday. Why would it not cross the x-axis? Ethan?
When there's no curve.
That would be a parabola though. It's imaginary, yeah. So if it's imaginary solution, then you can't use it. So when can you use it for a real solution? The other thing it helps is if they're rational. So with our technology now, if it's a 1.333 or 4/3 on the Desmos, you would be able to see where it's actually crossing. If you're doing it by hand, integers would be the best. If you're forced to do it by hand, you'd want integer solutions to see exactly where it's crossing that x-axis. But with technology, you don't necessarily have to have that. Alright, factoring, does that work always or sometimes? It is sometimes. We haven't looked at a whole lot of the ones that are not factorable, but there are ones that are not factorable. You just haven't been forced to figure that out. An example of something not factorable would be x squared minus 10x plus 3. There are no factors of 3 that are going to give you a negative 10. So this would be an example of a non-factorable quadratic. So then you'd be forced to go somewhere else, or one of these other methods. Does that make sense? Alright, square roots. Is it always or sometimes? Sometimes. When is it sometimes? Yeah, when there's no b.
Wait, when would it be used for factoring?
Oh, when it's factorable. Lost you. Alright, completing the square, just skip that one because we didn't do it, but it does always work. Quadratic formula, always or sometimes?
Always.
Always, every time this will work. And when, I would say any time that the other methods are not reasonable.
Let me just say anytime.
Anytime, well, let me put it this way, the other methods aren't efficient.
What if I like this method better? So are we not doing completing the square at all?
Not at all.
So we can cross out one over.
You can, yeah, you have to do it. So probably where it asks you to do completing the square, I'll let you use quadratic, so I have two options to do quadratic. Emily, did you ask the question I didn't answer?
So it says anytime the other method is unefficient. If that's my favorite method, that's fine, or do you prefer that we use it?
Everybody's going to be a little bit different. You will have to choose which one would be best to factor, because you have to choose which to put it in the boxes. Factoring is quicker. If the quicker you are at factoring, this one's going to be very quick. Not everybody's quick at factoring, but at Algebra 2 level, there should be ones that you're quicker at it. Square root method, I wouldn't want to use the quadratic formula if the square root method is available. There's no b term, because that's going to be a lot quicker than plugging it all in and doing all that.
Okay, that makes sense.
But, yeah.
What if we like state that we know the more efficient method, like we say something like factoring is going to be easier than quadratic formula, but then we tell you that, and then we do the quadratic formula.
Let me show you the next page, and that'll answer the question a little bit easier for you. You can see what it's going to look like. You have 4 equations along the top, and then you choose which one you're going to put where, and you can only put one in each one. Does that make sense? Alright, so one step to do this is to first find the discriminant of each equation and give the number and types of roots. And this is what we did, I believe, Thursday into Friday. Were you here for discriminant? I can't remember if we did Thursday or Friday, not that it really matters. But the discriminant is where we only had b squared minus 4ac. And that told us if they were real or imaginary. So if we use b squared minus 4ac for all these, it'll tell us if they're real solutions, if they're rational, and all of that. Imaginary. So let's do the discriminant for equation A. What is my A value? 1, good. What's my B value? Good. And my C? Good. Let's plug it into the discriminant. You have b squared, so negative 9 squared minus 4 times 1 times 21. What is negative 9 squared? We would get positive 81, don't forget. What is 4 times 1 times 21? Or 4 times 21?
84.
84, yes, we're going to be minus 84. And what do we get when we have 81 minus 84?
Negative 3.
Negative 3, good. When the discriminant was less than 0, what were your solutions?
2 real.
Not too real, but too imaginary. Because you're going to take the square root of negative 3, well, the square root of a negative number will be imaginary, and it'll give you 2 imaginary.
So, if it's less than 0, then it's always going to be 2 imaginary.
Every time, yep. When it equals 0, then it was 1 real. If it's greater than 0, it's 2 real. Alright, equation B. I'm going to skip the identified A, B, and C. Tell me what to write for the b squared minus 4ac.
Be 144, right? 0.
0, there's no b term, so it's 0 squared.
Oh, yeah.
Minus 4 times. Good. Wonderful. What is negative 4 times negative 2 times 144? Very good. What type of solutions do we get here? 2 real, very good.
So if it's a negative, it's imaginary. If it's positive, it's real.
If it equals 0, it's 1 real. Alright, how about our equation C?
It would be negative 22. We're okay. Yeah, negative 22 squared plus, no, minus 4 bracket 3.
Yep.
And then it'd be 7.
Very good. What is negative 22 squared minus 4 times 3 times 7? You can do it all at once. 400. Good. Greater than 0, so what are my solutions going to be? What system am I in? 2 real, okay. Alright, then equation D. Tell me what to write.
It would be 6 squared minus 1.
4 times 1.
Yeah, that's what I meant. And then negative 6.
Wonderful. 6 squared minus, what'd you get? 96. Perfect, 96. So what are my answers? 2 real. 2 real, very good.
I figured it would have had the 1 real.
Alright, the first thing I'm going to look at when I go to figure out what I'm going to put where is first I want to find the one that I can do the square root method on. That's very easy to identify. Which one am I going to do the square root method? B, because there's no center term. So the one with the center term, I'm going to go ahead and put in the square root method. So this would be B. Let's go ahead and solve it while we're at it. Well, what do I do first? Very good. So I get negative 2x squared is equal to negative 144. And what would that equal?
X squared equals 72.
Yeah.
And then since 72 is a perfect square, we have to.
Very good. Plus or minus the square root of 72, and then we're going to do the tree for 72. What does 72 break down to?
I got 8 and 9.
8, 9.
And 9 is 33. And 8 is 4, 2, which.
And then I look for my buddy pairs. I have a pair of 3s, so they break out and become 1 on the outside. Pair of 2s break out and become 1 on the outside. And then what's left over?
2.
Very good. And then what is 3 times 2? Very good. So that one's done. Alright, the other one that's easy to figure out is if you have one with an imaginary root. We know we cannot factor that one. So if you look down here, we have a complete the square and a quadratic. We're going to change this to a quadratic.
So why are we changing it to a quadratic when there's a quadratic?
I'm going to give you 2 to do the quadratic with.
Maybe A with it.
Hey, very good. We have to use the quadratic because there's a b term and there are no real solutions.
So for the next quadratic one, would it be A again?
No, we'll choose a different one.
Okay.
Alright, so if we're going to do a here, you could have put a here, so if you guys started to do this, kind of the a can go here too. A was x squared minus 9x plus 21. Another way to tell that this has to be the quadratic is if I think about my factors of 21, which is 7 and 3, 1 and 21, neither of them will give me a negative 9. So that's why it's not factorable, so you have to go down to the quadratic. Alright, so what does my a equal?
1.
B?
Negative 9.
Good, and C.
1.
I'm going to go ahead and have you do the quadratic on your own on that one, and I'll put the answers on the squared minus 4ac. So when I plug it into the quadratic, I have negative 9 plus or minus. I already know this is negative 3 because we did the b squared minus 4ac up there. Is everybody okay with that? Ethan?
Wouldn't it be positive 9 because of the,
Oh, opposite. Thank you so much, Ethan. And over 2. But we have to handle that square root of negative 3. We can't leave it like that. So what do I have to write it as? Take out an I, very good. We still have the square root of 3 left over 2. Nothing can simplify any further, so you just leave it as 9 plus or minus I squared of 3 over 2. These are your 2 imaginary numbers. So 9 plus I squared of 3 over 2, and then 9 minus I squared of 3 over 2. So everybody okay with that one? Alright, the next thing I would do is figure out if one of these is factorable. The first one I want to look at is equation D. Why would I look at equation D first?
Because you would have to do the second time.
Exactly. So it's really quick to figure out if it's factorable because we already know that 1 goes everywhere. If this one is factorable, it goes in factoring. If it's not, it goes down to quadratic, leaving us with C to put in the opposite place. So first, is this factorable? And how do I know? It is not. Why not?
Because there's nothing 15 and 6.
Very good. There's no factors of 15 that will give me a 6. So that one has to go down in my other quadratic place. So this is B. So x squared plus 6x minus 15 equals 0. So go ahead and do the quadratic formula with that one. We have 3x squared minus 22x plus 7 equals 0. We're going to do the slip and slide method. So your next step is x squared minus 22x plus 21 equals 0. Factors of 21, so will give us a negative 22, would be x minus 21, x minus. Then we have to take that 3 back out. We're going to divide each by 3. 21 divided by 3 gives me 7. This one, you're going to slide it back to be 3x minus 1. And then set each of those equal to 0. Alright, any questions on that page?